Okay, let's get started. So at the end of class today, there is a quiz, a take-home quiz, so make sure to pick it up at the end. And I'll try to announce it if I remember. What is happening next Friday? One person knows, so that means everyone knows. Okay, so midterm 3 is next Friday. Okay, I know it's coming up. So I haven't finalized the material because we're still a week and a half away, but it'll definitely include all the material on arrays and some of the next material, but I don't know how much yet. Any questions about that? I will be there for the test this time. Yeah. Yeah, same as last time. Mm-hmm. And sheet of notes, same as last time. And I'll try to include extra pieces of paper as well. Other questions about the test or assignment 5 or assignment 6? Yeah.
In assignment 5, go to the function setBit.
Yeah.
I just had a question about the ith digit. If you want to change like the first digit, say like an even number to an odd number, is that I equals 1 or I equals 0?
So it doesn't necessarily mean it's an odd or even. It just means that set bit is a term to mean whatever it was before, force it to be 1. So like if it was 0 before, make it 1. If it was 1 before, doesn't matter. It just means set the ith bit to be 1, no matter what it was before. So that means the first bit is the least significant bit. So the first bit on, if you're viewing the number left to right, so I'm trying to do it in your perspective, left to right. The first bit is the very rightmost one. Second bit is the second one, and all the way through. So if I wanted to set the second bit to be 1, for example, then I would go over here, not the first one, but the second one. I force that one to be 1. Okay.
Yeah, I just noticed that you said set if I is less than 0 or larger than 32.
Yeah.
So that means we're having overlap in one bit because we have 0 and 32, so that's the same value.
You're right. That should be at least 32. Okay. Yeah, so that means I'm looking at the bits 0 through 31, not 32. Yeah, I'll fix that. But any other questions about the assignment? This one or assignment 6? So who hasn't started assignment 6 yet? What do you think my advice is? Get started. Yep. Any other questions about the class or midterms or assignments or whatever? Yeah.
How many topics are going to be on the midterm 3?
So I just said this, but definitely the material on arrays. But in terms of the next set of material, which we will start today, it depends on how far we get through. Well, if we happen to get through everything of that, we'll include all of it and nothing else after that. But I don't know how far we'll get. Yeah.
So in your syllabus, the next PowerPoint is the last topic that we're supposed to cover, but we have another midterm. So
Class dismissed for a month, right? No. So the schedule I'm going off is way down here. So that's what I'm trying to go off of. But in the material up here, major topics up here, those are the things I am required to cover. But I can go to more other material if we have time, and we do. So other sections go into much more detail on each of these that I don't think is necessary. But being able to reason about the more exotic things of C++, because those are the things that people are actually using today, that I think is more important than going through every single sorting algorithm or ways that we can use arrays in classes, because we're going to come back to some of these. So there's some material on classes and arrays that, classes and objects and arrays that we don't know the material for it yet, but we will come back and visit some of these. But there are some things that are indicated down here that are much more interesting and important. Like, for example, where are we? So like polymorphism, for example, that is a way to reduce code among classes. So like if I want to make a class, like a car, for example, a vehicle, for example, and then I make a car class, it should inherit all of the stuff in the vehicle class because it itself is a vehicle. Well, with what we know so far, we can only make separate implementations of the two classes. They're not related to each other. Other ones like templates. So if you remember back on midterm 2, I asked you to make like the max function, min function, whatever. And I asked you to take in 2 integers by reference, but 2 integers, right? What if I wanted to make a max for double? What if I wanted to make a max for string? Like if I wanted to say, if one string is longer than another string, then that string is greater than the other string. But if they're the same length and one appears later in the dictionary than the other one, for example, how do we make that? Do I have to make separate implementations of those? Well, no, because of templates, we can actually make exactly one function that handles all of those cases simultaneously. So being able to do some of these down here builds off of the knowledge that we have learned so far and is much more used in how people really use C++. So that's why I want to get to this material and not stick with just the required material, because I don't think that's really what people care about anymore. Okay, does that answer your question?
Yeah.
Okay, cool. Other questions? Yeah, thank you for pointing that out. But I'm going off of the schedule down here. Other questions, though? Okay, so last time we were talking about quite a few different things. We started basically with 2-dimensional arrays, where we said that we can have arrays of arrays. So if I wanted to have, example, 12 exams right here, instead of having them just laid out in sequence like this, I can arrange them easier for me in columns and rows, so that I can think of, okay, this element is the 0th row, and in the 0th column. So now I can think, well, instead of thinking of a long flat array like this, I can think of a matrix, for example. So if anyone is doing any matrix computations, this is actually really useful. Because now if I wanted to look at the leftmost, topmost element in the top left corner, then I don't have to think, well, if I have a flat array, what is the index that I'm trying to seek there? Here, what I'm doing is just looking up the row and looking up the column. Super easy to use. But does the computer actually see rows and columns like this? Like, when I compile this down, does the computer actually see this in this way, or does it see it in a different way? Yeah, it sees it in a long flat array, because remember, memory is laid out in one long list of places in memory. It's not in some kind of grid like this. So the way that when you compile this down, it does something called pointer arithmetic, but the main idea here is it is able to figure out, okay, if I'm looking up this element, for example, how far along in this array do I need to go? Well, it knows exactly how many elements are in one row and exactly how many elements are in one column. So it says, if I want to look up here, I got to skip a row. Well, I know how long that is. And I got to skip one element in the second row, which is, and we know the size of that as well. So therefore, I can look up this middle element right here pretty easily. So, and if we can use initialization lists like before. So instead of having one curly bracket with a closed curly bracket at the end, we can have ones in the middle, which signify row, row, row. But row your boat, obviously. But you don't have to have these inner curly brackets because remember, it's compiled to a flat array anyway, so you don't have to do that. But it's easier to read and work with that way. But if we want to loop over a two-dimensional array, like, for example, if I want to print the elements in, if I want to print the elements in this 2D array, what do? Well, do I know how many columns there are in this array, this 2D array? Yeah, it's 3. Do I know how many rows are in this thing? Yeah, 4. So what I do is I can do this any order I want, but it depends whether you want to go by row, one row at a time, or you want to go one column at a time. Either approach is fine. It depends on the use case. So let's just say we want to go one row at a time. So the way we do that is I'm going to have a for loop which starts at index 0 for the column and then go as far as the columns go. What is the maximum column index here? 2, because there are 3 elements there are 3 columns and it starts at index 0. So I have a loop that goes from 0 to 2 for the column index, and for each of the columns I'm going to look at one row. So I'm going to have a row which is initialized at 0, and it goes through what number for the row? What is the highest index of a row? 3. So I'm going to go by columns and then by rows. Well, think about how what traversal is that? Well, if I'm going by columns, so let's say I'm on the outer index is 0 for the columns, and for each of the columns, I'm going by each of the rows. What traversal is that? Is that doing row traversal or column traversal? Column traversal. And we can actually see this in action. So let's do this. Let's copy this code in to look at the exams. So there are 4 exams here. So let's make an outer for loop for the columns here. And we know the highest index here is 2, so I put strictly less than 2, and then call plus plus. And then for each of the columns, I'm going to loop over each of the rows. So for int row is 0, row less than, well, the number of rows is, it's not a cough, it is, how many rows? 2, good. So row plus plus, and then we can see out exams of row. Well, I gotta access it by row. So no matter what order I do it in, I have to access the array by row, then by column. I can't do it in a different way. But I can go over the indices in a different way. So here what I can do is, let's just print them by new lines. So if we look at the output of this, then it says, okay, 84 we saw first, then we saw 92, and then 78 and 97. So in fact, we are doing this in a column traversal order. What if I wanted to do row traversal instead? Right, flip the 2 for loops around. So it's actually really easy to do. So if I just cut this out, put it here, and then and we run it again. So I just flip the 2 for statements. Now we do it in row traversal order. So it depends what the use case is. And in some contexts, row traversal is better, and pretty much every context, row is better. But sometimes column traversal is better. So it depends what the use case is. But it's pretty easy to switch from one to the other if you need to, just by flipping the 2 for statements there. Any questions about 2D arrays? Okay, so then we, of course, generalize this to n-dimensional arrays. So I can have as many dimensions as I want, as long as I specify how big each of the dimensions is. So that's no issue. I can have arrays of objects, as I've said before. You don't have to have arrays of some types. You can have arrays of any type that you want, which is kind of nice. But then we talked about this godsend called the vector class. And so the issue we saw with arrays was what? What was one of the big issues with arrays? With flat arrays in C++?
Bounds checking.
Oh, sorry?
Bounds checking.
Bounds checking, yeah, that's an issue, but there is a way around that, and I'll show you a way. But what's the fundamental flaw with arrays? They have a fixed size. So the fact that we have a fixed size and we can't grow or shrink them, that is an issue. So a vector solves this problem for us. We have to include this header, of course, but I can have a vector like an array of any type. So if we want a vector of ints, we got to put it between the less than greater than sign here. And when we get to templates, you'll get to see why it's like this. Yeah.
Just wondering, is there an example where arrays would be better than vectors?
Almost never. So the only reason why I would ever use a flat array, well, two reasons. Why I would use a flat array versus a vector is if there is an old API that accepts arrays and not vectors, then I should pass a flat array to them, like a native array, not a vector. But of course, I can change that API if I want to. And there are ways of converting a vector to a native array. So there is a way around it. But one of the other issues is, although this is extremely exotic, is if you have some code which is needs to be super efficient and it cannot waste one single clock cycle, sometimes with vector, you can, it has a tiny bit of overhead compared to an array, like a normal array. So in like very, very high performance code, then you probably should use a native array. And even then, only if you can guarantee the array doesn't need to grow or shrink. Because if it needs to grow, then just use a vector anyway. So only in very exotic circumstances would I ever recommend someone using an array, not a vector. And even with that, there's a class called array in the standard library, which has a fixed size array anyway, and that has no overhead. So even then, I almost never recommend anyone using a flat array, a native array in C++. Use vector if you need the array to grow and shrink. Otherwise, use the array class in the standard library. But any other questions? Okay, so here we can have any type of vector that we want, and we can set an initial size, just like a normal array we could. And with square brackets, we can access things just like an array, no differences there. I can initialize it in many different ways. I can set the initial size. I can set initial value with the size. So I have 20 elements here, all initialized to 0. So if I wanted to initialize them to be 100, for example, that'll work equally well. I just put 100 here instead of 0. But if I want to copy a vector from one to another, that's also possible. So I just pass a vector, which is called finals here. I just pass it to another vector, which I call scores here, and the elements of finals will be copied over to scores. And so I can copy things over, yeah.
Is it like, can you use like a reference for that too, so that you like, move it over?
Well, so this is actually a really recent type of issue. So do you want to copy the values over, or do you want to what is called move them over? So like they're not here anymore, they're over here instead. So here what I think is communicating is finals I still want to keep around, but scores I want to be a separate vector. So this is what is called the copy operator. So I'm copying the elements over. But in the copy, so actually we can look this up. So great question. So if we look up vector copy constructor, then if we look here, which is the copy constructor, it should say if it loads. If we look at the things that, the types of the copy constructor we can have, if you look at here, the copy constructor takes a const reference to a vector. So you're right. It does take it by reference here. But I can still loop over it in exactly the same way. So a good question. So here, if we want to copy a vector over, it's better if we don't have to copy the vector first in order to do the copy anyway. And to declare it const here, because of course, when I'm copying things over, I better not modify the original. So that's why that's here. Any other questions about vector so far? But of course, if we want to add elements to a vector, what is the method that we call? Anyone remember? But pushback, yeah. So if we want to add elements to a vector, we just call the pushback function. And then here in the argument, we just say what the thing is we want to put into the vector at the very end. If we want to insert something at a particular location, maybe it has the function here. Yeah. So if we want to insert something into a vector, we have to look up the position that we want to put something there, and we haven't really talked about that yet. But there are ways to be able to put something into a vector and then shift the other elements right one position. So like I'm making room for this one element to be there. But barring everything that we've done so far, we can just assign one element of a vector just like before with the square bracket operator. Okay, so that's pushback, to push on the very end of a vector. And if we want the size of the vector, which was a little cumbersome with arrays, but we can do with vector quite easily. Just call the size function. Yeah?
With 2D vectors, how would size work?
So it depends on what we do. So I was actually going to get to 2D vectors. So you're a little ahead of me here. But can I have a vector of vectors? So one person says no, other people say yes. What do you think the answer is? I'll take the union of your answers to be the class's official answer. So what do you think? Yeah, so let's try it. Well, I don't get a compile error. That's good. So let's just say that if I wanted to see out scores.size here, so what do you think this size is calling? What is it in terms of scores? What is that representing of the scores 2D vector? Well, think of the 2D array example where we had two-dimensional arrays. What if we wanted to know the number of dimensions on the outside? What does that tell us? So like if I wanted to know the if we wanted a 2D array which is first indexed by rows and then indexed by columns. If I wanted to know the length of the 2D array itself, does that give me the number of rows or the number of columns or something else? Number of rows. Yeah. So here, this tells us the number of vectors that we have as elements. So just like if we just had a normal vector like this, size tells us the number of ints that are in the vector. But if instead we had this, it'll tell us the number of vectors in here. So you could think of this as the outer index corresponds to rows, just like before, and the inner index corresponds to the columns. And we could do it in the very same type of way. So I could access the row of 0, so that's on the outer index, and the inner index corresponds to, okay, the index of the inner vector. So what could be possibly an issue with 2D vectors? Yeah.
Well, I don't think this is an issue. It's an do it, but like when you're using pushbacks,
Mm-hmm.
you're adding to that. So you're adding pretty much just another vector, right?
Mm-hmm.
You use pushback only. How would you add to the inner vector?
Good question. So if I wanted to add to the, say, the first index, so index 0, what I would do is scores of 0, which is a vector, dot pushback. Yeah, so remember scores of 0? That's just referencing the element inside here. So it's referencing a vector, and then now I can do operations on that particular vector. Yeah, so if I wanted to do the same thing with index 1, I would just change that to a 1. But if I wanted to just push back 75 on the outer scores array, that won't work. Why? Because 75 is not a vector, and so I can't actually push back an integer to be a vector. But if I make a vector like this, let's do it this way. So if I make a std vector, actually we don't know what that is yet, but let's do vector of int. I'll call it n, and then I'll make it with one element and initial value is 75. Then can I push n back in here? Yeah, because the scores vector now, this 2D vector, is trying to push back a vector. Can that work? Yeah, that's fine, because I'm pushing back something of the same type as the vector is said to be. So I'm pushing back a vector into a vector, but I said that this thing is a vector of vectors, so we're okay here. It's the same thing as if I just said int here, and then I say int n is 75. It works exactly the same way. Although this statement won't make sense anymore, but it works exactly the same way. So if I push back something of the same type as what the vector says it is, then everything is fine. Yeah?
So we kind of talked a little bit about how it's a little bit difficult to return an array from a function. Can you write a function that returns a vector?
Exactly. Great question. So I can make a vector. So that's the return type of, let's call the function f, the most original name, by the way. Let's make this. So let's copy this code in. But I need to actually say what the type is here, right? I need to put the thing between the angle brackets. So I put int here, and everything is fine. And then maybe I don't want to have to retype vector of int. So what is a way I can do that without having to retype it? A four-letter word which starts with a and ends in toe. Auto, yeah. So if I want to say result is f, then the result type is what? What is the type of result? It is a vector of int because, actually, this is not quite right. There. Now it's correct. So I'm returning a vector of ints from here, and so I'm assigning it to here, so results type is vector of int. Okay, so I can return vectors from a function. I can actually return any type from a function if I want to. So if I have a custom type, I can do that. I can do vector. Here's something that's really interesting, though. What if I change this to be double? What else do I have to change? The return type. Doesn't that seem kind of annoying? Anyone know of a way that we can fix that? Yes. So I can actually put auto in the return type. So this is a really recent feature, like within the last 3 or 4 years or so. So here I can actually have the compiler deduce the return type for me, so I don't have to retype it, which is kind of cool. But the key here is that I can return a vector from a function if I want to. Any other questions, though? Yeah. Well, if I have it here, then it wouldn't know what those scores word is. But if I put it here instead, it'll still work fine because it's still returning a vector. Yeah, so there are some weird things that you can do here. Like you could, in really recent versions, have 2 different return types depending on what was passed in. So I can have a vector of int in one place and a return vector of double in another place, and it would compile and run completely fine. But we're not to there yet. But any questions on vector so far. Yeah.
When it returns scores, like, what does it actually,
Where does it what?
when it says return scores, what does it return? So when it says it's returning back all values.
So, great question. So here, I'm not initializing it with anything. I'm not putting any values in. I didn't set an initial size, so it's just an empty vector. So there's nothing special in here. I could, for example, put 20 here, which means I want 20 elements in here. So they would return a vector which has 20 elements. But I could put anything in here that I want to. So as I can return any object that I want to, which is a vector in this case. Yeah.
Is there a way to get around when you want to return an array to not just return the address of the array, but to actually return an array?
Yeah, so but the thing is that arrays by themselves are references, so you can't really get around that.
So is there a way to return an array and then call it and then actually get to that array, like set another array equal to the array from the function above?
So I think one of the other slides said that you can't just copy elements, like by setting this equal to another array, it doesn't copy the elements over. So, but there was a way that we can use a for loop to copy the elements over, just by looping over all of them and then just copy them. With vector, the vector equals another vector will work. So it depends on what you're working with. If you're working with a vector or an array, the answer could be different on whether you can move things over or not. Other questions? Okay, so we can grow a vector, but what is the other one we haven't covered yet? Shrinking a vector. So maybe we want to make the vector smaller. So one way you can do that is the function was called pushback, and then there's a corresponding function called popback. Anyone happen to know what push and pop correspond to? It's okay if you don't. It's something called a stack, but we haven't talked about stacks yet. But the key here is that popback is just going to look at the last element and remove it from the vector as if it wasn't even there anymore. So, so that's kind of nice. It's just like the opposite of pushback. But if we want to remove all the elements from the vector, we can just say the vector dot clear. And so it'll just empty the vector as if nothing is there at all. Another function to check, well, I don't want to actually empty the vector, but I just want to check if there actually is something in there. So what is one way other than this function at the bottom? How can I check whether there's anything in the vector at all? What about the size function? If the vector is empty, what should size return? 0, right? So I could, for example, say in this while loop, while not scores.size equals 0. And so that would work exactly the same, yeah.
With scores.clear, does that keep the size of the vector? Does it set all values to 0?
Great question. So you're asking questions that I don't know the answer to. So let's actually see. So let's make a vector of int and called scores. Let's just say there are 20 things initialized to 100. And then we call scores.clear. And then let's just see out the scores.size. And then if the size is 0, then I can't print anything and there's nothing in there. So, oh, okay, so there is nothing in there. So it really does empty the array. But actually that's not necessarily true. So a vector on the inner part of vector, there is a native array inside of there. So when I do this, when I do clear here, does the internal representation of the array have to free up the inner array? Does it have to do that? No, it doesn't have to. It could just lie and tell me, yeah, there are 0 things in here. And so that's one of the interesting things about object-oriented programming. You could return a result and say, yeah, there are 0 things in here, but really the array is still there. And then when we do pushback, well, the array now better not have anything addressed that we can get to other than what was pushed back. So we could think about how is vector really implemented on the back end. Well, we could just implement it this way. Let's suppose that we've called pushback 10 times, for example. No matter how large the array is on the internal part of vector, what indices should I access if I pushed back 10 times? Well, I should only access indices 0 through 9, because those are the things that I should ever address in a vector. Should I access the other elements in the native array, even though I didn't push back? No, I don't think that's a really good idea. So thinking about how a class is really implemented is something that's pretty interesting. How is vector really implemented? And so I invite you to think about how it actually works there. Yeah, we can actually check. Let's go to vector. So go to declaration. And so this may look horrible, but let's see. So let's look for pushback. So pushback is in, okay, so I think this is the header, and it doesn't have the implementation in here. So let's go down. Okay, so yeah, this is more complicated than I thought it would be. Okay, so it should be in this function right here. So it takes a const reference to some element that we want to put into the array. So this, even though that I have no idea how vector is really implemented, and I doubt any of you do either, we can actually get a lot of information just by looking at some of the source code to try to think about what really happens here. So what do you think this if statement does just by looking at it? You don't necessarily know what these actually do, but what do you think they do? So it's saying here, if this end, whatever the end variable corresponds to, we haven't talked about this either, but it's some variable. If this end variable is not the end cap, whatever function that is, what do you think that is doing? So here's what I think happens. So as we're pushing back elements into the vector, we're maintaining this end variable, which is the highest index that we can access. Okay? So if we're not completely full on the internal array, if we're not completely full, just move this end one place over and put the element right there. If we're not completely full, then there's still room that I can just put something there. But what if the array on the internal part of vector is full? And so we're at the very end with this end variable. We can't move over one position. So what do you think vector should do? What do you think it actually does? Here's what I think it actually does. So here's the full array now, but I try to push something back. What it does is it allocates a completely brand new array twice the size as the old one, and it copies the elements of the old array into this new array. And so now there is room for me to push back. So this is what I think actually happens. And if you look here, it actually is moving that position over one place. So this is actually something really interesting, and I invite you to do this, to go look into the source code of how things really are implemented and try to figure out what actually happens here. So we can actually get quite a lot of information here. But some of these things, of course, we don't necessarily know how they work, but we can get a general idea at the very least. But any questions about vector in general? Yeah.
Can we put a number in argument for popback so it doesn't just remove the last one?
Great question. I don't know. So let's look at vector popback, because let's try to remember some stuff. If I have two functions of the same name, but one has different arguments than another, what is that called? Overloading. Yeah. So let's look at all the possible overloads of popback. So let's see. So, okay, so there is only one function of popback. So there's no overload for a particular value. That could be something to ask the standardization committee. Can we have a popback that passes in the value, and if that element is that value, pop it back, and otherwise don't? That could be something that could be interesting. But as is, there's only one popback here. Other questions, though? Okay, so let's move on to so from here on out, basically what we're trying to do is having a higher level understanding of not just C++, but coding and algorithms and all of that in general. So if we have a vector or array, whatever, what is one of the fundamental issues with this? If we have, like, let's just say we have an array or vector or whatever of 100,000 ASU students, or maybe thousands of faculty members. And let's suppose that they're trying to find me in that list. What could be the issue? Or they're trying to take as requests thousands of people asking for the class search. So you know that class search and how it's really slow some of the time? So I used to be a web developer here at ASU, and I actually was almost able to get class search faster by over 20 times. So sometimes, like, searching for biology classes or whatever takes 30 seconds, and I can get it down to 1 second. The issue that I had was the number of people, the number of seats that were open, that was a time-sensitive data. And so the way that I was implementing it, you couldn't access that information in real time. So unfortunately, I couldn't check it in. So, but the key there was I was thinking about how am I accessing the data inside the class repository of the classes in class search. Well, if you have 100,000 ASU students, how should you structure your data so that you can find people efficiently? But another one that's interesting is in the grade book, it's normally sorted by your last name. But what if I wanted to say, well, I'm going to sort by, let's say, midterm 1 score, and then I'm going to sort by midterm 2 score, and then sort by midterm 3 score after that. And then I want to make sure that the midterm 1 score's relative order is the same. I don't want to mix up the midterm 1 score and then when I'm trying to sort the other 2 columns. So thinking about how does search actually work? Can I make a faster search? Can I make a faster sort? Those are very fundamental questions. But think of this, for example. Suppose you're looking up a word in a dictionary. Actually, let's play a game instead. So I'm thinking of a number between 1 and 100. And what you're going to make repeated guesses to me, and I'm going to tell you whether your number is too high or too low compared to my number. I'm not going to tell you the number, but if you hit the number, great. If not, well, I'm going to tell you whether it's too high or too low. So the number I'm thinking of is between 1 and 100. What's your first guess? 50. So your number is too low. So what should be your next guess? 75. Why? Why are you not searching below 50? Because you know from my answer, it cannot possibly be in that half of the numbers. So you're bisecting the list of numbers in half every time. What about if you're looking up a word in a dictionary and you don't know where the A's start, where the B's start, where the C's start, or wherever? You don't know where the letters are, and you're trying to look up a word in the dictionary. Where should you look first? Let's say the pages are indexed 1 to 1,000. What page should you look at? Or aim for? 500. Why?
So you know which direction to go.
You know which direction to go to because the dictionary is in sorted order. Because the dictionary is in sorted order, and you look up the element right in the middle, you can compare. If it's less than this element, it must be in the first half of the dictionary. If it's greater, it must be in the second half. So I can cut half of the list away. But what if the list isn't sorted? Can I make any assumption about where the element is? No, I have no idea. So I have to linearly search through the list. So in fact, having our data in a particular way can make our algorithms much faster. So what is a search algorithm? So a search algorithm is you have a list, an array or vector or whatever, and you're trying to find something. So if you have a list of ASU students or a list of classes or whatever, you just try to find that class that you're searching for in that list, okay? So if you're trying to look up Ryan Dougherty in the list of instructors at ASU, then you're trying to find my name in that list. So nothing too interesting there. But two of the main algorithms that most people use are called linear search and binary search. So what are those? So linear search is you're going to linearly scan through the list from beginning to end or the other way. You go from one end to the other. And what you do is you look at the first element. If it's equal to your element that you're searching for, great, you just found it. If it's not, march forward one position and try again. And then if it's not, try again at the third one, and then so on until the very end of the list. So if I'm looking for 11 right here, I look at 17, the first element, which is 17. It's not equal, so I march on to 23, not equal, 5, not equal. Oh, I just found it. So is 11 in this list? Yeah, it is in the list because I scanned through some positions and then I eventually found it. Is 6 in this list? No, and how can you tell? So, well, we look through each of the elements and it says not equal to every single position in this array. And so therefore it's not in the list because it never said equal at any point. So like for 7, it's not there either. So we have to examine all of the positions. So obvious trade-offs. The benefits is actually easy to do because now you just make a simple for loop that goes from index 0 to the length minus 1 and then add 1 every time. And then just check. If the ith element is equal to the thing you're searching for, great, you're done. Return true or whatever. And the other great thing is that the elements can be in any order. I don't care what the order is, I'm just searching for the element. But the disadvantage is that it's slow. So I'd be careful in saying this for kind of advanced reasons, but I can go into them if you want. Because if you have a really long list, on average, if we don't assume anything about the order, I have to examine half the elements on average. So that's one of the main issues with linear search, is that it's slow because I have to examine half the elements on average. But if we assume that the list is in sorted order, so that is a nice motivation to sort things now. So if it is in sorted order, we go to the middle index. I don't know what the value is necessarily, but I go to the middle index and I look at the value that's there. If the value I'm searching for is less than that value, then it must be in the first half of the list somewhere. Well, must it be in the list at all? No. But if it is there, it must be in the first half. It cannot be in the second half because the list is sorted. So if the middle element has the value, great, we're done. Otherwise, you look at how it compares to the middle element. If it's less than, it's in the first half, or at least you should search in the first half. And if it's larger, you search in the second half. And then if you just keep repeating this, at some point you must be checking an empty range. Because we're cutting the list down in half every time, at some point we're going to be checking 0 things. But if we haven't found it by now, then it's not there. So if we have this sorted list, for example, If we look for 11, that's the middle element because it's the middle index. Great, we found it. If we're looking up 3, for example, we look up 11 first, then we see, is 3 less than 11? Yeah, so therefore I search in the first half of the list, which is 2, 3, and 5. And then the middle element there is 3, and then we found it. Yeah. So that is an interesting thing, and we'll deal with it next time. I'll see you on Friday. Quizzes are right here. Make sure to pick up your quiz. They're sorted by last name.